All right, so the question is, determine the empirical formula of silver oxide by experiment. All right, so an empirical formula is really just a mole-mole ratio of the elements within a compound. And so by experiment, you might determine the empirical formula of silver oxide by knowing the number of grams of each element. You'll know the number of moles of each element, and therefore you'll know the mole-mole ratio and the empirical formula. And so a common way of determining this is by placing silver oxide within a crucible. A crucible is a small ceramic container which can be heated and hopefully doesn't crack upon very heavy heating. Now, you're able to heat, if you put silver oxide in it, you're able to heat it to the extent that oxygen evolves off. So that oxygen is left as a gas and silver remains as a solid within the crucible. And so by heating the silver oxide within the crucible, you're able to separate the silver from the oxygen and then determine the mass of each one. And so some experimental data might be collected. For example, the mass of the initial crucible might be 16.795 grams. The mass of the crucible with that silver oxide might be 17.317 grams, and the mass of the crucible and the silver metal that is 17.283 grams. And so you would like to know the number of grams of each element, and so you can do this by, for example, determining the difference in mass between the crucible with the silver oxide and the crucible with just the silver. The difference in mass between these is the mass of your oxygen. And you can know the mass of the silver by knowing the difference in mass between the mass of the crucible and the mass of the crucible with the silver. And so calculating these masses can be done as so. So the mass of the oxygen, again, is the difference between the mass of the crucible and silver oxide and the mass of the crucible and silver metal. And so find the difference between these. So 17.283 minus 17.317 grams minus 17.283. So the difference between those is 0.034 grams. And you can also find the mass of the silver. That's the difference between the mass of the crucible and the silver metal and the mass of just the crucible. So that is 17.283 minus 16.795. And that is 0.488 grams. And so now you have the mass of both elements. Now you can find the number of moles of each one. And so you have that 0.488 grams of silver, and you might know that the molar mass of silver is 107.86 grams per mole, and so you can calculate that we have 0.00452 moles of silver. And the mass of oxygen, converting into moles, gives us 0.00212 moles of oxygen. Now, in order to determine the mole-mole ratio, you need to divide these moles of each thing by the smaller number. Because this 0.00212 is the smaller number of moles, you'll be dividing our number of moles in both cases by that. Okay, so divide both numbers of moles by that smaller number, and then you are left with silver is 2.13 and oxygen is 1.00. We're saying that there are approximately 2 moles of silver for every mole of oxygen here, and there's 1 mole of oxygen for every 1 mole of oxygen. And so that allows us what looks like an empirical formula of silver 2.13, oxygen 1.00. Of course, you know that by Dalton's laws, we know that we have simple whole number ratios of elements versus each other. You can't have 2.13 silvers per every oxygen However, you could have 2 silvers per every oxygen. You see, we rounded that 2.13 to 2. There's kind of an exception to this rounding, however. Sometimes you might be finding that you have ratios of, say, 1.33 to 1 or 1.66 to 1. If you see a 0.33 or a 0.66, that generally means that you should multiply the number of moles of everything by 3. So you might find that 1.33 times 3 is 4, and 1.66 times 3 is 5. By multiplying these by 3, you get whole numbers and whole number ratios between your elements. If you find that you have a 0.5 as one of your numbers of moles in your mole-mole ratio, then generally you'll multiply by 2. So if you have 1.5 to 1, multiply by 2, and you get 3 to 2. Now, we just kind of did a shorter calculation where we went from grams of each element into the empirical formula. But sometimes you'll be given percent by mass of an element. For example, instead of telling you to do this experimentally, I might have told you that silver is 93% by mass. Actually, silver oxide is 93% by mass silver, and silver oxide is 7% by mass oxygen. Now, having these percents by mass, you can assume that you have 100 grams of compound. And so if you have 100 grams of compound, then you have 93 grams of silver from that 93%, and you have 7 grams of oxygen from that 7% by mass. And so that gets you into that 100 grams, having grams of compound. And so basically, if you're given percent by mass, just assume that you have 100 grams of your compound. All right, thanks for watching, guys.